were built. And as we worked through the process with DEM, for me, it came to, most importantly, I want to clean the waters up in Roger Williams Park, because as the person who's in charge of Roger Williams Park and in an organization that needs revenue, 100 acres of a 435-acre park that is quote unquote unusable is a problem. So beyond the fact that we should have been abiding by the MS4 permit and the reason for the consent agreement, I actually, in my interview for this job 6 years ago, when the mayor asked me what my biggest problem was in the Parks Department, I said water quality in Roger Williams Park, biggest problem. Beyond funding, biggest problem. So it was always my intent, and I'm a resident of Edgewood, I live right outside the park, to make these waters better. So ultimately, that was the goal of the whole thing. So this drawing shows structural and non-structural BMPs throughout the park, and this is growing every day. And you can see some of the examples of what we've done. Innovations, which we'll talk about a little later, but mainly with forebays, which is where the sediment is collected, as you all may know, and becomes the biggest part of the maintenance and the biggest reason why these will no longer function. So we've done a lot of research on how to get the water in, how to treat it, how to use it. And again, through the collaboration of all these different stakeholders or groups, we've developed what we feel is a real good center of knowledge for stormwater innovation. So personally, for me, this started before the consent agreement. As a contractor for 26 years, I worked in Roger Williams Park on 5 of the stormwater sites, of the 6 stormwater sites that were constructed prior to 2015. And as I went through that process, and I built over 200 of them of those structures as a contractor, I continued to see what I felt were mistakes in design, mainly because it was difficult for me to construct these things, and then I could only imagine how difficult it would be to maintain these things. So out at Polo Lake, we were building the structure, and there was one day where the engineer came out, and we had a heated argument about his design and what I felt was insufficient, and asking him why they're still designing things like this. And I think from that conversation started this idea of there's got to be a better way, you know. And as a contractor, I had a unique set of experiences, and then coming to the city of Providence, it expanded my experience beyond the construction of these things and the small amount of maintenance that was required to do on the contract after building it, to really being afforded the task of maintaining these things properly and seeing how we struggled, my staff struggled to do that. And through that experience, we kind of decided that tempering design with maintenance in mind is what needs to be done. I'm not saying you're going to design solely for maintenance, but you should, all these designs should be tempered, and that's location and depth and elevation and all different things. So this kind of a unique position, because a lot of my counterparts in different cities may work for DPW, they may work for planning, and I think when a stormwater BMP is considered and then constructed and then maintained, there could be 4 or 5 different staff members that are involved in that. The planning department may be the one that gets the design going. They hand it off to their design, to their project management team. Then that person hands it off to DPW or Parks, whoever is maintaining it. So the transition may be difficult. The maintenance people weren't getting involved in the construction and therefore couldn't provide their input. Here in Providence, in particular in Roger Williams Park, I am in charge of everything from concept through maintenance. So I had the full view of what was happening here, and therefore could bring all those different people together, and through that collaboration, talk to the designers, have the maintenance people talk to the designers. As a contractor, I knew the struggles we had. We brought other contractors in to talk about their other struggles and tried to dial down on what the issues were related to constructing these, paying for these, maintaining these. So all those things came to play for me because I had a unique opportunity to drive the entire process, which maybe some of my counterparts don't. So I think in short, that's kind of how this all came together. And thank God I met the other people on this on the screen today, and they did what they do best and got this off the ground, because certainly I didn't have anything, had no knowledge of doing that. And I am so thankful for their assistance and expertise. And then the Innovation Center was launched, and researchers are involved and a whole bunch of people involved that I'd like to talk about later. But through this group, I think we've made substantial changes in stormwater management. And every meeting, I learn a little something, and every meeting I look forward to some new innovative technique or product that this team brings to fruition. So with that, I will pass it back to you, Meg.
Thank you, Brian. So Brian Kopp, our stormwater coordinator, will now talk a little bit more about the Innovation Center.
Okay. Thank you, Brian, for kicking that off. And thanks, DEM, for letting us talk a little bit today about some of the current activities and programs that we have going on. So Will and Holly and I will kind of walk you through some of the activities and programs that we're working on right now at the Innovation Center. So as Brian said, trainings, that's one of the focus areas at the Innovation Center. And so this year, we put together 5 different trainings that were related to stormwater and green infrastructure, mostly focused on the design and the construction and the maintenance aspects. And our original plan of having this being a great place-based training center to take advantage of all the innovative designs and the high concentration of BMPs and green infrastructure in the park sort of got delayed because of COVID. But the silver lining of that, we were able to put on some virtual webinars, and those all got recorded. And so those are recorded, and they're there forever, for better or for worse. They're there. We all were learning how to put on these virtual trainings, but they are all available. And this fall, we plan to get back to the in-person trainings if everything safety-wise is appropriate. And then, then we'll have part of the trainings will be an in-class, and then the other part of the training will be in the field, getting to look at all the green infrastructures projects, how they've changed over the time, because there's a wide variety of ages of the BMPs in the park that, some went in 5 plus years ago, some went in 2 years ago, some are, currently even going in. So with the trainings, we'll be able to incorporate all the different BMPs in the park. For these trainings, they're pretty well attended. On average, we had 75 people that attended our virtual trainings. Over time, we'll see if how we're able to keep the attendance up, whether or not we'll have to switch things up and offer a different curriculum for the trainings, or if we can stick with the curriculum we have now and just repeat them less frequently. The pie chart down here is sort of a breakdown of the people that attended the trainings. We do hope that for the in-person trainings, when they're in the park, for the maintenance and construction trainings, that we will have a higher percentage of field staff and contractors that are present, so that we can focus more on the hands-on portion. In the virtual setting, it was difficult because a lot of the maintenance staff, they don't have easy access to laptops or computers as part of their job. So instead, the people that attended the training were probably the supervisors of the maintenance staff that we really want to connect with and get information to. We also then did a residential guide to stormwater training. The other trainings were focused more on the professional aspect, but this training targeted community members and homeowners and presented them with information on how to decrease runoff from their property, and tips so that they could, still keep a nice yard, but use less fertilizer or chemicals, information on how to size and install a rain garden and rain barrels on their property, that overall will improve the water quality, not just in Roger Williams Park, but in the state in general. Okay, some of our other projects that are going on, we do a lot of monitoring, and we are trying to better understand with some visual assessments how green infrastructure performs and functions, both in the short term and in the long term. And we've developed this visual assessment program to get an idea of whether or not the maintenance frequency is adequate to keep the BMPs working, and just if certain design features are working over the long term. So we go to the sites and conduct a site visit of the BMPs on a monthly basis, and also do them after any sort of large rain event. And then whenever possible, try to get there during a rain event, because that's when sort of all the real cool stuff happens. And during that site visit, we'll take photos, fill out a checklist about visual characteristics and functions like erosion. Is there erosion happening? Are there dead plants? Is there excessive sediment in the forebay? Are the inlets functioning properly? Is there standing water in the treatment area? All things that are really important and important to document. And that way we just get a better idea of what's working and not working. And then we try to take that information and data and incorporate that into some of our trainings. And we also recently set up some, up here in the corner, some time-lapse field cameras that we put out right before a rain event, and they are hopefully going to provide some valuable insight into what happens during a rain event, because it is hard to get the timing correct to go out and manually visually assess some of the BMPs. So we're hoping they'll produce some pretty cool videos that will then be incorporated into the trainings. Just some examples of a rain event last summer that was part of a visual assessment, or just when it was raining, I said, I got to get out there and see what I can find. This first example is an example of a BMP in the park that is basically functioning perfect. It's just got done storming, coming down, the stormwater is entering the catch basin, going through a pipe down here into the forebay, and no problems with any sort of debris in the inlet. Water's coming in great. And then there's also no issues going through the Gabion weir. This right there is the Gabion weir. So this is filling up. It's not overflowing because there is an overflow bypass at the upstream side of this BMP rather than at the downstream side. Water's perfectly going through the Gabion weir and then into the treatment area and functioning exactly the way it should be. So that's good. Second video down here is an example of one that it's functioning. So you can see some kind of ponded water, pooled water here. This is the inlet structure right here. And so it's ponding a little bit. It is making it in. You can see the trickle of water here. It's not maybe coming in exactly at the rate that it was designed to, but overall it's functioning pretty well. And as you can see here, this is a secondary inlet that comes off of this big giant parking lot up at the Botanical Center. And actually the majority of the flow, I think, comes from that parking lot, and that one is functioning just as designed. This third example down here, moved you guys to a spot. Okay. This is these are all during the same rain event where it was raining at, I think it was only about a ½ inch of rainfall, but it all happened in a very short time. So a real high intensity rainfall. And most of the BMPs were full of water, but this one you can see that as I run over here and try not to get wet with the video, that BMP that forebay should be filling up, but most of the water is bypassing that inlet, and it is because this inlet was clogged. And this design here was a design that Wood Environmental and Brian came up with to keep this sidewalk handicap accessible. But I think maybe we are finding that that it does make a handicap accessible walkway, but it does require a pretty high level of maintenance to keep that inlet free, because debris and leaves and stuff still are entering that inlet underneath that grate right there. And then this fourth example up here, this is just an example that most of the BMPs you could see had water in it. This one, for some reason, the water is the storm flows are bypassing this inlet, and we're not exactly sure why. It could be that the storm was localized and that This area didn't actually get as much rainfall as the rest of the park. Could be that this inlet isn't steep enough. It could be that the roadway has eroded a little bit. So yeah, still some unanswered questions that you really can't find the answer to with the visual assessments. So another aspect that we're doing is performance monitoring. And we do this by installing pressure transducers into 3 locations in the BMP. We do one at the low point of the forebay, one at the low point of the treatment area, and then another inside a monitoring well that are in most of the BMPs in Roger Williams Park. And we log data every 5 minutes. And these pressure transducers are measuring the pressure above a certain point, which then can be converted into a water depth once you subtract the atmospheric pressure. And then we also survey the BMPs so that we can come up with a volume of water then that is entering the system for a specific sized rain event. And then we compare that data with precipitation data that we're collecting in the park. And we do this just to, one, verify whether or not it's functioning, and maybe you just missed the timing of when you were there to see if water has been collecting. But then to also sort of compare it versus the real world versus the modeled or theoretical world, and see if those volumes are the same. We do have enough pressure transducers to monitor 3 BMPs at a time, and so we sort of rotate those throughout the year, and eventually we'll have enough data and information on all of the BMPs in the park, and have an assessment of whether or not they're functioning, and have the data to back it up. And then again, incorporate that into the trainings. And the last thing that I'll talk about is some of the in-pond water quality monitoring we're doing. So we are participating in the URI's Watershed Watch volunteer monitoring program for the 2nd straight year. And we are monitoring at 6 locations around the pond. So we have 6 great volunteers last year and 6 great volunteers this year that go out weekly and bi-weekly to collect chlorophyll and dissolved oxygen information. And then monthly and quarterly, they collect a water sample that they will take to URI to be analyzed for bacteria and nutrients and alkalinity, I think. But this graph here shows that this is the 2020 data. I just got it, so I haven't had time to do too much analysis on it, but this is just mean total phosphorus concentration. This is 2020. And then the dotted line is sort of the threshold of what is considered to be, if you go above it, it's an impaired water body. If you're below it, then it's considered not to be impaired. Not much changed from 2018, which was the last data set that I had, to 2020, but I haven't been able to go in and look at whether or not that's, there's some correlation between, temperature, and there was a drought last year. So we'll find out, and hopefully things will be improving over time. But the good thing is that we do, like, the orange dot is the number of samples taken. So that has definitely increased. So we are probably getting a higher quality data set, if anything. One other thing that we're doing is working with URI and UNH to do some continuous water quality monitoring at both the inflow to the park and the outflow to the park. So this photo right here is all the equipment that we have installed. We have a UV vis spectrometer that will do continuous measurement of nutrient samples as long as you, or concentrations, as long as you calibrate it with some sort of sample. And then we also have a YSI multi-probe that measures specific inductance, temperature, chlorophyll, pH, stuff like that. And then this one up here is we have some hobo loggers in and have developed rating curves for the inflow and the outflow to the pond. And so we will eventually have a nice data set of concentrations, water quality concentrations, and stream flow, and then we'll be able to produce some pretty highly accurate load estimations. So that's sort of what we have going on as far as water quality and BMP monitoring. And I'm going to pass it off to Will.
Okay, the truck is on the back of the lot with the bicycles. I'm walking out there now.
right, can everyone see this slide here? We're good?
Yep.
Awesome, thank you. So we, in addition to all the various suite of monitoring that Ryan talked about, I'll talk about a couple more initiatives we have, and one of them is the Cyanobacterium Monitoring Collaborative, which is an effort led by the EPA to better understand the enabling conditions and for the proliferation of cyanobacteria. So you can see here, this is Dr. Hilary Snook with his mobile EPA lab here, giving a public presentation and demonstration for the importance of monitoring cyanobacteria and how to go about doing it. And so why cyanobacteria? I feel like many of you are probably familiar with why we are monitoring for cyanobacteria, but just briefly, they're a microorganism that, while it's naturally found in water bodies under the right conditions, usually warmer water temperatures and excess phosphorus, they can develop into a bloom and dominate the water column. And so this is harmful to the ecosystem and the ecology because they can block out sunlight, outcompete other organisms in the water body for nutrients, and reduce oxygen availability. Also, what is very pertinent to a place like Roger Williams Park, where you have many visitors who are in close contact with the water, is some species produce harmful toxins that can be toxic for wildlife, pets, and humans. So this is an area of especially high concern for the park. Here we go. And so with the monitoring collaborative, we have 3 tiers of monitoring. And so users of the system can choose to participate which ones they would like to do. And so last year we did the Bloom Watch and Cyanoscope, and this year we're adding cyano monitoring. So Bloom Watch is an app on your phone that we're hoping to train volunteers and use ourselves to observe and report observations of potential cyanobacteria blooms. So you can see a photo here that can get uploaded along with a few other parameters and some photos to the Bloom Watch app. And it gets stored on a website called citsci.org that is accessible to the EPA. And you can see here on the right some of the observations we had from 2020. And one thing we're hoping to improve with this is it's great to pipe this information to the EPA, but we'd like to find a streamlined way that this information can be shared with DEM and Department of Health as well, so it can potentially trigger responses from across the state. So and the second tier is Cyanoscope, where we're actually taking water samples, and you can see here this is a plankton tow that my colleague Heather has pulled, and we take samples and plate them up on the microscope, and we have volunteers who are able to collect them and then also look at the samples under the microscope, and we're able to take photographs of the various species, where they're occurring, what the time of year, and we'll upload them to iNaturalist. And so here we have Warrenachinia and Dolichospermum, 2 potentially harmful toxin-producing species. And then this one is just one that I think looks really cool called Pediastrum. And so with these first 2 tiers, last year we held twice a month, we held volunteer activities where folks could come and learn about cyanobacteria, all the nutrient reduction initiatives we have in the pond, and then actually go take samples and look at their samples under the microscope. So this in cyanobacterium or cyano monitoring here, the 3rd tier is looking at more of trying to get at the density and the population distribution of these cyanobacteria. And so on the left here, you can see a sample. We use dark bottles for this. This is just an old picture, but you take a sample, you run it through the fluorometer, which is able to measure the fluorescence intensity of phycocyanin, which is a pigment fairly unique to cyanobacteria. So in addition to measuring phycocyanin, it also measures chlorophyll A. And so we have some fixed sites across the water bodies that we'll measure this summer. And hopefully, in response to observations or events, we can do more targeted sampling as well. And one goal that we have as well is to use a hemocytometer to actually look at the cell densities of these samples and compare them to the fluorescence of the phycocyanin and the chlorophyll A. And another initiative we have in the park is picture posts. This is an initiative that was designed by the University of New Hampshire, but is now curated by University of Oklahoma. And it's essentially kind of a low-cost way of gathering observational data. So it's a post with 8 sides here, as you can see in the photo. And so user can place their cell phone or camera on each of these sides and take a photo, and it gets uploaded to the Picture Post website and cataloged. And so what you end up with is 8 photos of a site, kind of a panorama. And the goal is to make it easy to use for people. So we have a QR code that you can use to take you straight to the app or the website. And we have 10 of these across the ponds, the park. And so we really are trying to use these for 2 reasons. One is to document how these BMPs progress and mature over time. And then the other is we have them placed in areas near the ponds to see if we can observe cyanobacteria blooms as well. So here's one on the left that you can see a time series of a BMP that was recently installed and see the vegetation grow. And though this is, I would say, not super useful maybe to the park, because it does have so many eyes. The managers and park maintenance is there all the time. And so you have a lot of eyes on these BMPs. We were testing this methodology out to see if it could be used in areas that maybe don't receive so much attention, and so that you can have folks take these observations and send it back so that managers can see, from their office whether or not BMP requires maintenance or what. So on the left, you can see the vegetation growth and the ongoing maintenance, and so these will continue to generate these time series. And I have to give a big shout out to the Fogarty Center. There are rockstar volunteers who have been going out every week to take pictures at all 10 picture posts throughout the park, even through wintertime. So that's been very helpful. And here you can see, though we're learning it's kind of challenging to identify cyanobacteria blooms through these photos. Partially where they're located and the angle of view you get on the water is challenging. We have observed some of them here. And so this last one here, I'll admit, this is not just because, I'm not saying this just because Brian's on the call here, but it was hard to find a photo of a BMP in need of maintenance and with debris buildup. I think it's a testament to how much attention these BMPs get. But this is a photo just showing an example of an observation you can have that may trigger a maintenance intervention or something. So you can see a lot of, where this is how the BMP should look. And then here it is with some leaves and some debris and sand in the forebay there. So hoping that this could potentially be used to trigger maintenance. So that's all I've got, and I'll pass it on to Holly now. Let me see if I can stop sharing.
You're on mute, Holly.
Okay, thank you. Thank you, Will. Okay, so I'm going to share my screen. Oh, dear. Okay. Let's see. Okay.
Just hit the presenter view.
Okay, thank you, Meg. All right. So I'm here to talk about the Rain Harvest Arts Festival. And last October was our inaugural festival. And it's all about bringing the information that you all have been hearing about from the experts into an art and science festival in a fun, interactive, and creative way to draw attention to the green infrastructure at Roger Williams Park. We wanted to raise awareness about urban water quality and stormwater. So the leaders of the group, even the big group, the collective, wanted to include professional artists, And so I got brought on board, and then I brought a couple of more artists on board, specifically to do murals. And you can see one of these murals in the center here. This is by Dawn Spears, who's an Indigenous artist. And then down here you can see there's the public as well as artists working on a mural by Andrew Esch that sort of illustrates how stormwater works through these green infrastructures. And then on the science side, there's cyanobacteria sampling that is shared, and identification demonstration of, which is what Ryan talked to us about, and Will. And then there's people stationed at a registration booth that's at the boathouse, and at the various murals, the 2 murals engaging the public about stormwater and green infrastructure. And we also gave educational tours of the Bmps. So it was a great inaugural event. And so we decided to do it again this year. So this year, leading up to the festival, we started a pilot program which introduced stormwater and green infrastructure curriculum into local schools. And 3 schools were selected, partly based on proximity to the park and connections to April Alex from the Parks Department and myself from previous work. Eden Park Elementary 5th grade, Sophia Academy 5th grade, and the New Urban Arts Knights from Central High School after school program all participated in this project. And with the help of Lisa Maloney, Tracy Hall, and April Alex from Audubon and the Parks Department, the students experienced 2 science sessions, and they were introduced to the concepts of the water cycle, watersheds, stormwater runoff, and green infrastructure. And there were also some take-home messages. Don't put trash in the storm drains, pick up the poop, don't feed the geese, and harass your parents about not using so much fertilizer. The overall goal is what happens to water when it rains, what pollutants stormwater picks up, and that stormwater goes directly to water bodies, and some green infrastructure solutions that can help. And this year, due to COVID, we had to do virtual sessions, but next year we're hoping we will be able to all meet in person. Let's see. So the next step is we're trying to take the science concepts that the students learned to working with 3 teaching artists, Katie Guy, Eli Shalan, and Brett Wyndham, to use the knowledge that they've gained from the scientists and creatively come up with a storm drain mural design, which will help raise awareness and help them understand, where the stormwater goes, how it can harm habitat, and whatever other things they think of. And once the drawings are complete, the teaching artists created a final design to incorporate all the students' work. And in each of the schools, 2 to 3 storm drains were selected near the schools, and we had to obtain permits and permissions from the city of Cranston and Providence. And in Cranston, we had to actually work with homeowners, because many of the storm drains were in front of people's homes and weren't right near the school. And so it was really interesting and a wonderful way of the students doing outreach, because they had to go home and see where the storm drains were near where they lived. And a couple of them got actually to have their storm drain by their home included in this project. And one of the students was just thrilled that there was artists working on a mural outside his home, and said it was his favorite part of the project. So through the whole process, we're documenting the work with the students. The teachers are helping us as well. And we are interviewing the students, after they've seen the murals in process, and talking, getting them to share with us what they thought were some of the best parts of the project and what they had learned. So we're creating a documentary video, which we will share at this year's festival. So it's really told by the students what they learned, and they're actually communicating with the public and educating the public. And these are a few of the responses from the students about what they thought before they took the class. And some of them are pretty fun to read. Okay, so this, some of you all may recognize, this is the Seal House at Roger Williams Park. And on the day of the festival, this is where we will showcase all of the students' designs and the video. And we all hope that you can come on June 12th. The event will be from 2 to 6 p.m. And here is a map of the activities that will be happening that day. And if you can set your eyes, this is the boathouse, so you can get acclimated, and that's where you will come at the to register and to get a map of the activities that will be going on. And you can also get the paper from Audubon for a scavenger hunt, and you can visit our partner organizations. We'll have tables set up, and flag distribution. So let me tell you about the flag. So if you follow this line here, this is a path that will be indicated by a series of flags, like prayer flags. And at that entrance, you can get a flag that you can add to this flag trail. And the flags will be made out, we'll have printed on them hand silkscreen prints of some of the students' drawings. And if you go along here, you can pick up some chalk and do some chalk drawing inspired by the storm drains. And if you keep following along here, you'll come to the Seal House, and that's where you'll see the video and the students' work. And you can also partake in a guided tour of the stormwater projects there, as well as the microscopic viewing of what has been found in the water. Will show you that. And then, let's see, where's my pointer? Then up further, you'll find a new mural will be created by New Urban Arts Nights, so you can watch some artists at work. And then if you want to come back here and then go across the Iron Bridge and then down this path, you will come to Storyteller Hill. And this is where we'll have a land acknowledgement done by Dawn Dove, who's a Narragansett elder, and Sussy Santana, who is a spoken word poet from the Dominican Republic, and Sharente Harris, who's a Narragansett performance artist, will be telling stories, as well as Len Cabral. And all of these stories will be inspired by water. And then you can make your way up here or go back down the trail, and up here at 4:30, we'll have a power washing of Andrew Esch's mural. And the purpose of this is in recognition of the maintenance staff that maintain the park, as well as a demonstration of how the storm drain project handles water flow and the dry paint. And also, Roger Williams Park is a historic site. So nothing can be done to change it permanently. So we really do have to get rid of the mural. And then at 5 o'clock, you can, or 5:30, start heading down here back to the boathouse where there will be a finale performance with ERB Brass Band and Lisa Bottamarco. And that will be the pond performance finale. And you'll have to come and see what that is. But so we'll be open from 2 to 6, and we will also have food trucks there, and hope that you all can make it. So thank you very much. Meg, back to you.
Thank you, Holly. I almost started talking with my mute button on, like we all do. Well, great. We're going to give it back to Brian. So the Providence Stormwater Innovation Center was established to do all the things that we have shared with you today, but also to push the limits a little bit on stormwater treatment, try out different things, see if we can improve the effectiveness of stormwater management and the ability to long-term maintain stormwater practices. And Brian's going to share with us a little bit of some of the work that's ongoing around the innovation side of things. And then if he takes about 5 minutes, we'll have a few minutes for questions. If people want to put questions in the chat, I'm happy to keep an eye on them, and we'll try to get you done by 1. So turn it back to you, Brian.
Thank you, Meg. So, I think you'll see now that the stormwater innovation is doing much more than innovating stormwater practices here in Roger Williams Park, but that is a big part of it as well. And I think the key is collaboration. So we are collaborating with many different stakeholders and regulatory agencies. DEM has been a big part of our leadership team and attended those meetings. The researchers from UNH and URI, the consultants who have not only done their designs by contract with the city, but have also participated in the trainings and a lot of the things that we have done. They've bought into the Innovation Center and what its potential is. The owners who become the maintainers, they've been here. Different cities have come to our trainings. The stakeholders, which you have them on your screen now, and many more beyond that. The environmental and civil engineers, landscape architects, contractors. So we enlisted the contracts and got contractors and got their opinions of the designs they built throughout the state and beyond, and what their issues were and problems were. The manufacturers have come and showed us their research and development stuff, what the next best and greatest, and we started testing some of those things that they had provided to us. And then the community organizations like WRWC and Groundwork RI, participating in trainings and apprenticeship programs, which is desperately needed throughout the state. So innovation is a byproduct of these roundtable discussions, these trainings that we've done, the research data that we've obtained, and then the other data beyond the research that UNH and URI is doing is the data that we are collecting here in Providence. It's the man hours required to maintain these structures. It was the man hours required to build these structures, because we do build elements with our own staff here. The dollar amounts that we paid out to hire contractors to do these things. So all of this information was missing from UNH and URI's research by their own admission, and kind of closes the loop on all of this if we continue to monitor and provide that information to them. Some of the designs we've concentrated on is the forebays. The removal of the sediment often is the biggest problem in maintenance. And we've really looked at the forebays as a key part in keeping these BMPs function. If we can stop the sediment from getting to the treatment areas, then they will function longer. So just quickly, river rock was something that I, as a contractor, riprap, river rock, installed routinely as forebays in stormwater. My issue with river rock is it's typically installed with 12 or 15-inch depth. So while it takes a long time to fully provide all the sediment, put all the sediment into that trench to a point where it's no longer functioning, it's very difficult for a owner or a maintainer to determine when it is no longer functioning. Because sometimes the sediment will run off the top of the river rock, and unless you actually get down there and move it, you really can't tell. So we've abandoned River Rock as a floor bay here. And now our crews do what we lovingly call a drive-by. So we have permeable pavers. When once a quarter of an inch of sediment has gathered on that permeable paver, it is removed very easily with a broom and a shovel. And while we may end up going there 5, 6, 7 times a year for 15, 20 minutes, the other side of it is the removal of the river rock swale that we have here in the park is an all-day event with multiple laborers, operators, backhoes, and trucks. So we are monitoring those costs, and we are seeing a better maintenance of these sites with less time and less effort. So certainly that's one of our things we're most proud of is that sediment forebay. But we are still gauging its functionality as we move through the year 3, 4, 5 on some of these elements. How water gets in, the inlets is something we've looked at. There's a big question as to whether you should allow all the water that comes to a point to go through the BMP, or if you should use a roadway, let's say, through a curb cut as your overflow. Allow the low flow to come in, treat that water, but when it's inundated, have that water continue on, not go through the BMP. Different consultants that we've hired have different schools of thought on that. So that's something we're developing too. Different types of wares, the gating baskets you saw, those are something we're experimenting too. Then the latest thing we're working on with the SNET network is the Mr. Potato Head tree filter. So typical Rhode Island Mr. Potato Head, we have certain elements, how the water gets in the inlet, the forebay, how the sediment's removed, the wear, and then the treatment. So basically, as a way to guide counterparts of mine in other municipalities, state officials, or even private homeowners, what they're actually looking for an inlet, we'll give you 4 different options. So the nose, the mouth, whatever you want to call it, will tell you that these are the 4 options that you have to choose from, depending on your condition of where you are and what abilities you have to do to construct these things. Pick one of these 4, it'll work for you. Then the forebay, here's your options: river rock, pavers, mortared riprap, all these things. Here's your options. What would you like to see here? And here's some examples of it. And then the wares and the treatment. So you kind of build what you're thinking of before you ever enlist the services of a consultant. So you're driving the design based on information for maintenance and construction costs and effort that we will provide to you. And we'll give you an idea of which way we think you should go. But ultimately, the biggest problem that we're facing, not only here in Providence, but throughout the state and country, is the maintenance of these stormwater elements. We can build them all day long. We get the funding to build them, but we don't get the funding to maintain them. And what is the point of it all if after 3 to 5 years, they're no longer working? So how you do the maintenance? Well, that depends on how it's designed, how close it is to the roadway, what equipment is needed. So certainly tempering design with maintenance in mind needs to be done as these things continue to be built. It's often overlooked in the design part of it. So when are these things maintained? Again, with the river rock, it'll be months, but it could function for weeks, if not months, without you knowing it's no longer removing sediment, because the sediment's washing over the top, and you can't tell that by looking at it. So make it so it's easily discernible that the element needs maintenance, and it'll happen more often, and the maintenance is much easier. So who has the ability to do this? That's the other question we talk about. Well, here in Providence, we trained our staff. There's other municipalities that may have 3 or 4 people in a DPW department. They may not be able to train them, and certainly may not have time beyond filling potholes and otherwise to do that. So who is that entity that's going to provide for training personnel for the maintenance of these things? Again, the ultimate goal is to keep them working. And then where's the money coming from? So there's got to be some movement on how municipalities and private homeowners maintain these things, be it with funding, training, expertise, or whatever else it is to get this thing done, because ultimately that's not what's happening across the state. So in a nutshell, we provide real world data, not a laboratory setting. And as you saw on one of the slides, the good, the bad, and the ugly, we're willing to put that out and learn from it and get people coming here. But that was the information that was missing from much of this research that now we hope to provide to these people that can have a true effect on stormwater management here and beyond. So I will turn it back to Meg.
Thank you so much, Brian, and thank you all for the presentation. I just put the website for the Innovation Center in the chat. We have a lot of information there on the website. And I see some thank yous coming in on the chat, and we thank you for joining in. And if you have any questions that come to mind, or if you want to have a tour, we would love to give our DEM friends a tour of what's going on there. So just let us know. Ryan put his email in the chat. Most people have my email as well. I'm going to see. Amanda says, keeping water as close to the source. Good point, Amanda. Yeah, there's a lot we can do there. We didn't talk about all that we're doing. We're doing some additional work on public education at the Seal House and getting some displays put together. And Amanda, your point is one that we should be thinking about as we put that together. So thank you all. We really appreciated the chance to come speak to you during lunchtime.
Thank you.
Thank you.